Well, in class, we are looking at section 3.6, derivatives of logarithmic functions. Okay. And so we covered a bunch of sections here. And as a result, there are a lot of differentiation formulas we need to know. And we are adding more as of this section. So a lot of formulas here. The only new ones are at the bottom left. That we are going to cover regarding logs. These formulas, again, they will be discussed shortly as to how we arrive at it. All right. One of the things that is important to be able to handle this section is being comfortable with properties of logs. As far as the general idea behind log is that it is simply an exponent. So if we see the log and we see the exponential, as we can go from one format to the next format easily, we are in good shape. If we have a problem with this transition, then log becomes difficult. Okay, now on the left side, you see the general rule. Okay, log 1 is 0 regardless of the base. Log b base b, that means if the base and arguments are the same, the answer is 1. The third and the fourth one, log of b to the power of x base b or b to the power of log x base b, they refer to the fact that logarithmic functions and exponential functions are inverse functions. They undo each other, they give us x. The next one is called the product rule, the quotient rule, the power rule. Now notice the same thing when we have base e, y equals ln x, e to the power of y equals x, and it repeats accordingly. I hope you remember that for the common log, the base is 10, and this is known as change of base formula. Okay, log x base b is log x over log b. Now you can choose any base a or base 10 or base e. All right, so let's get now we are dealing with an exponential function. We're going to differentiate this, and we're going to differentiate this implicitly. The left side, the derivative of any exponential function is itself. So e to the power of y. Then by the chain rule times the derivative of the exponent, so times y prime or dy dx. The right side is x, the derivative is simply 1. So what is y prime? 1 over e to the power of y. Now e to the power of y is x, so you replace it. Y prime is 1 of natural log. Simply look at the argument and flip it over. 1 over x. What if it's not x, it is a function of x? The chain rule applies. So you flip it over and you multiply by its derivative. Therefore, it gives rise to the following. Okay. ln of absolute value of x is 1 over x. X can't be 0, of course. And by the way, this is important when we do the reverse process and we go for the integration. X, okay. So d dx of ln u is 1 over u and then du dx. In other words, the chain rule says you multiply by the derivative of the function. If it's g of x, flip it over and then multiply by its derivative. So what do we mean? Let's start with a couple of very, very simple examples. Number one, You see the formulas. The top right gives us the formula, so that is really not a big deal. So we want to differentiate this. ln, okay, so flip this over. That means 1 over 5x minus 1. Step 1, 1 over 5x minus 1. Just flip it over. The chain rule says times its derivative, g prime of x. So what is the derivative of 5x minus 1? 5. And you just rewrite it. Simplify whatever your algebraic technique tells you. Y equals ln x cubed. There are two ways to do that. I'm going to show you. And ultimately, the more complicated the question, the faster the second method. Okay. Sticking with the first method, we are looking at this one. It says flip it over. So 1 over x cubed. 1 over x cubed. Then it says we need, by the chain rule, we need the derivative of the argument. X cubed, the derivative is 3x squared. So 1 over x cubed times 3x squared. Rewrite it, and it becomes 3 over x. This is simple enough that we do it this way, or the second method makes no difference. Here's the second method. If you go back to this function, how do we rewrite this log? How do we simplify this log? This exponent sits in front, and it becomes a coefficient. So that's a very simple differentiation. So 3 times, now ln x gives us 1 over x. And therefore, 3 times 1 over x is 3 over x. It is extremely simple, and we've done it. Okay, class. All right. As I mentioned, you can do just the old method, flip this over, and then take the derivative. But to take the derivative, you need to do what? The quotient. So it's easier to decompose this log. So can anybody tell me how you would decompose this completely? In other words, your logarithmic properties. What do we get? Anyone? To decompose this, we say log of the top minus log of the bottom. This is called the quotient rule. So what is log of the top? What is ln of 2x? Is ln 2 plus ln x, and then minus ln of the bottom. So this is complete decomposition, class. Now, if you wrote this as ln of 2x, that works out. It's not a problem. But if you decompose it completely, it's a lot easier. So let's do this one by one. ln 2, it is a number, 0. ln 2 is a number. ln x, 1 over x. Minus ln of the parentheses 2x plus 1. Flip this over, 1 over 2x plus 1. And then by the chain rule, times its derivative, which is 2. You're done with calculus, and I'm sure your algebraic techniques can finish this. You are taking a common denominator. By the way, this 2 is the same as being at top. So 1 times 2x plus 1 minus 2 times x over x times 2x plus 1. I'm assuming everybody knows what's happening here. I quickly show you. So we are saying that this is 1 times 2x plus 1 minus 2 times x. And the numerator simply becomes 1. And that's your final answer, class. That is your final answer. Okay. Okay. Let's do the next example. 5x ln x squared. Again, you can do it the same way, or just first simplify this because it is ln of x squared. 2 sits in front, becomes 2 ln x. So 5x times 2 ln x becomes 10x ln x. Okay, 10x ln x. So now that we have that, it is the product rule. Product of 10x and ln x. Product of 10x and ln x. 10x gives us 10 times ln x plus, let me just put this raised dot in between. So this is 10x times ln x. So 10x gives you 10 times ln x. Ln x gives you 1 over x times 10x. Okay. So this is 10 ln x. And what is this? 10. And so what do? You can leave it like that, but it's a good practice to take the 10 out. Either way is fine. It's not that big of a deal. So 10 ln x plus 10, or 10 times ln x plus 1, that is our final answer. All right. Now what do we do? Quotient rule. Everybody remembers the quotient rule? F prime g minus g prime f over g squared. So the derivative of the top is 1 over x times the bottom x minus the derivative of the bottom is 1 times ln x. And you just write the denominator squared. So again, 1 over x times x minus 1 times ln x, and the bottom you just write it and square. These two, the product is simply 1. So 1 minus ln x times x squared. I hope everybody is clear as to how we arrive at it. Okay, it's pretty straightforward, everybody. It's pretty straightforward. All right. The most important part, which makes this easy, would be the knowledge of logarithmic properties. So we want to decompose this before we differentiate. We want to use our algebraic techniques. How would you decompose this completely? Anyone? Decompose the natural log. What do we get? Anybody? Okay, we want to decompose this. So ln of 3, we use the product rule in conjunction with the power rule. ln 3 plus ln x plus ln of x plus 4 to the power of 5. 5 sits in front, and this is the complete decomposition. So again, this last one is ln of x plus 4 to the power of 5. 5 sits in front. This 5 doesn't belong to the whole gang. It just depends. It belongs to x plus 4. That's why it sits in front of ln of x plus 4 only. Now, one by one, we are going to differentiate. So this step is algebra, is knowledge of properties of logs. ln3 is a number, 0. ln x, 1 over x. Plus 5 times, now what about ln of x plus 4? 1 over x plus 4 times the derivative of the parentheses, which happen to be 1. Okay, so maybe I write this so we are clear as to what's happening. So we get 0 here, 1 over x here, 5 times 1 over x plus 4 times the derivative of x plus 4, which is 1, and it gives us the next step. Now this is simple. You combine them. 1 times x plus 4 plus 5 times x. Okay, 1 times x plus 4. I'm assuming everybody can add up fractions easily. 1 times x plus 4 plus 5 times x. That's what we get in the numerator, and the denominator is the product. And you keep it as a product. You don't have to distribute. And the numerator simplifies. X and 5x, they add up, and we are done. It's pretty straightforward. Product rule. Okay. Let's put a raised dot in between. And now it's a simple case of a product rule. E to the power of 2x is e to the power of 2x times 2 times ln x. And ln x is simply 1 over x times e to the power of 2x. So e to the power of 2x times 2 times ln x by the product rule, okay? E to the power of 2x times 2 and then times ln x. Then ln x gives us 1 over x times e to the power of 2x. So you can rewrite this by factoring out e to the power of 2x. When you take e to the power of 2x out, the first piece just gives you 2 times ln 2. The second piece gives you 1 over x. 1 over x. It's pretty straightforward. Okay, 1 over x. All right, so let's move on. We want to differentiate the log. We know how to differentiate natural log. We knew how to differentiate the exponential when the base was e. When the base changed, then we did some sort of properties to figure out, and we do exactly the same thing here. We know how to differentiate natural log, but if it's not, what do we do? Then we can use the change of base formula. Okay, so we know log x base b is ln x over ln b. Please bear in mind, when we say ln x over ln b, I want to rewrite this for you because I want everybody to understand the meaning of this is the following. So this is the same as writing 1 over ln b times ln x. So why am I writing it in this fashion? Because I want to point out 1 over ln b is just a number. So it is like 5 or 10 or any coefficient that you have in your mind being multiplied by ln x. So when you want to differentiate this, this is not going to go anywhere. This becomes 1 over x. So 1 over ln b times 1 over x. That would be the derivative. And you just write it as 1 over x times ln b. Just the reason you write it that way, because ln x gives you 1 over x. You don't want to write ln b and then x. One may be under the assumption that the argument of natural log would be b times x. That's why we put the x in front. Okay, so from here, you get 1 over ln b. Maybe I write in front of it just quickly. This, the derivative would be 1 over ln b times 1 over x. And we can write it in this fashion. Okay, so that's the derivative of a log. Okay, therefore, we can expand it to chain rule and say, what if it's a function? Okay, so remember, if it's a function, you flip over the function 1 over f of x, and then you multiply it by f prime of x. That is the part that you already do. Because the base is not e, don't forget the ln b is there, 1 over ln b. So first and foremost, for this one, we are going to rewrite this as what? Square root of x changes to x to the power of 1/2. 1/2 sits in front. So first we do algebraic techniques of decomposing the log. And now, so I hope everyone understood what happened. This is x to the power of 1/2, everybody. We are changing this one to x to the power of 1/2, okay? And so 1/2 sits in front. Now, so 1/2 is there. What is the derivative of log x base 3? So you flip it over 1 over x, and then because the base is not e, okay, 1 over natural log of that base, whatever it may be, happen to be number 3. So 1/2 is there. Then this gives us 1 over x. Because the base is something other than e, we divide by natural log of the base. And now we are going to rewrite this. And notice the way we rewrite it. We write the 2x in front. Again, we don't want to put it in the, after number 3, then it may be confusing as to what we are writing. We don't want to do that. All right. Now, let's take a look at this one and see what happens, everybody. Okay. We are dealing with logs, therefore we flip this over. So 1 over x squared plus 1. The chain rule says we need the derivative of the parentheses, which is 2x. We look at the base is not e. So the rule says 1 over natural log of that. So 1 over x squared plus 1, we just flipped over the argument, times 2x, chain rule, times 1 over ln 5, change of base formula. So I'm going to repeat this because I want everybody to know which rule is used and what. You flip this over because you're differentiating the log. You're multiplying by 2x because of the chain rule. Then 1 over natural log of 5, this is the change of base formula. Change of base formula. Now put them all together. Okay, put them all together. It's important to see if you put ln 5 in front, one may think it's ln of 5 times x squared plus 1. Don't do that. So it's a good practice to write it in this fashion. Okay, everybody? All right, we've gone over the proof for E, and if you recall, we proved this with the definition of a differentiation. And we looked at this too using the college algebra style or even intermediate algebra style. But let's look at it from a point of view of calculus with a better process. So to prove this, we start with the fact that ln x, we learned the derivative is 1 over x, and of course f prime of 1 is 1. So f of x is ln x. F prime is 1 over x. If we replace the x with 5, becomes 1 over 5. If you put it 10, 1 over 10. So if you put it 1, is 1 over 1 or simply 1. So this comes from the fact that f prime is 1. Now let's go with the definition, okay? And let's look at the derivative by definition, okay? Everybody remembers the definition, right? So if I want f prime of 1, okay? First of all, f prime of x is the limit as h approaches 0 of f of x plus h minus f of x over h. I want f prime of 1, let's define it. And we already know f prime of 1 is 1, so we are going to manipulate this and get one of these in a moment. Okay. Now, of course, f of 1, okay, class f of 1 means what? ln of 1, and ln of 1, everybody knows is 0, right? So ln 1 is 0, okay. Because ln 1 is 0, it goes away. This is ln of 1 plus h over h, or 1 over h ln 1 or 1 plus h. It's just the way you rewrite this. Bear in mind again, let me just write that. ln 1 is 0, everybody, okay? And so having said that, because remember, because of the logarithmic properties, the coefficient, when it's the exponent becomes a coefficient, so you can make it a coefficient. And so it practically gives you the answer. We know it's f prime of 1, right? And we know f prime of 1 is equal to 1, so this is the answer, okay? Okay. And so we continue with the fact that f prime of 1 equals 1, and we set this equal to 1. Now, if we put e on both sides in the following manner, e to this power, e to this power, okay? Or just rewrite the natural log. Either way is fine, okay? So what we are saying, e to this power and e to the power of 1, they are the same. I hope everybody understands. You can, in essence, you can say, e to this power, e to this power. Okay, so that becomes, okay, that's another. And so what happens here, you can interchange limit and natural log. Okay, so this is the limit, okay, of h approaching 0 of e to the power of natural log of 1 plus h to the power of 1 over h. And I hope you realize that by logarithmic rule, remember e to the power of ln x is x. So let me just write that for you too. So recall e to the power of ln x is x. That's why this piece just becomes its exponent. Okay. And believe it or not, that's a proof. By the way, h or n or x, it makes no difference. Okay. And so you can see that let n equals 1 over x, and then n goes to infinity as x goes to 0. And that's the proof. This gives you this one. Okay, remember h or n or x, choose as long as you have the following the same. This one must be the same as this one, must be the same as this one, meaning you replace the h with anything you want as long as those three are the same. That's why you see x here, x here, x here, that's fine. And then of course, remember you can replace the x with 1 over n, x approaches 0. If x approaches 0, n approaches infinity, and so on and so forth. So that's the proof that is using calculus. Okay. We are going to go to the next example. Okay. We are interested in finding the equation of a tangent line. The good old equation of a tangent line needs two things: a pair, it has it, and the slope. To find the slope, we differentiate this using the product rule, which means the derivative of x squared, which is 2x, 2x times ln x, plus the derivative of ln x, which is 1 over x times x squared. 2x times ln x plus 1 over x times x squared. So 2x ln x doesn't change, but this one simplifies to x. Okay, All right. Now what happens? Now, in order to find the slope, we're going to plug in x equals 1. So if you plug in x equals 1, 2 times 1 is 2 times ln 1. ln 1 is 0. So that goes to 0. Just becomes 1. So if the slope is 1, y minus y1, so y minus 0, equals m, which is x, times x minus x of 1, which is also 1. So use this one to come up with the answer. I'm hoping that nobody has any problem with that, okay? It's pretty straightforward. All right. The next topic we're going to cover here is going to be logarithmic differentiation. As far as logarithmic differentiation is concerned, you take the following steps. Number one, you take a natural log of both sides. This works when you have a complicated function. You differentiate implicitly with respect to x. You solve for dy dx or y prime. So, what do we mean by that? Look at this and how complicated this is. If I want to differentiate it just the way it is, I can do that, but it takes a long time. But with logarithmic differentiation, this becomes a piece of cake. So my first step is to take a natural log of both sides. Okay, so what happens if I take a natural log of the left side is ln of y. What about ln of the right side? I hope everybody can see that we're going to decompose it. I want to decompose the right side. ln of the top minus ln of the bottom. This gives me ln of x to the power of 3/4. 3/4 sits in front. X squared plus 1 to the power of 1/2. 1/2 sits in front. Minus ln of the bottom 5 sits in front. Now this is your algebraic technique, and I hope you know that, class. Okay. So we get 3/4 ln x plus 1/2 ln x squared plus 1 minus 5 ln x of 3x plus 2. Now we're going to differentiate both sides. Okay, so the next step is differentiation. So how do we differentiate? What is the derivative of natural log of y? You flip it over, 1 over y, and then the derivative of y is y prime or dy dx. That's this. Then 3/4 times ln x gives us 1 over x plus 1/2 ln of x squared plus 1. Flip it over, 1 over x squared plus 1 times 2x minus 5. Flip this over, 1 over 3x plus 2 times the derivative of itself, which is 3. So take a look one more time. ln y, 1 over y dy dx. 3/4 ln x, 3/4 sits in front. ln x gives you 1 over x. Plus 1/2, 1/2 is intact. ln of x squared plus 1. Flip this over times 2x. Minus 5 times, flip this over times 2. Okay. We're done with calculus, that is. So you rewrite this and solve for dy dx. So let's see how we do that. Number one, you can multiply both sides by y. I hope you see what happens to 1 over y goes to the other side. Let's look at this one. 3/4 times 1 over x becomes 3 over 4x. The product of these two, 2 and 2 cancel each other. So x over x squared plus 1. Minus the product of these two, 5 and 3 gives us 15. We are practically done. So what is y? What is y? Plug it in, and you are done, class. You are done. Okay. Very simple. Okay, so we are looking at logarithmic differentiation. Okay. Another place that logarithmic differentiation is helpful, and it's important for you to know, is when you have a function to the power of a function, you know how to differentiate if you have a function to the power of a number. If you have a number to the power of a function, okay? So what happens if both of them are functions, okay? Then you do logarithmic differentiation. So take a natural log of both sides. This becomes ln y. This sine x sits in front, becomes sine x ln x. So please understand what happens. Again, if the base is a number, we know how to differentiate. If the exponent is a number, we know how to differentiate. But what if both the base and the exponent are functions? Then logarithmic differentiation is one way. There is another way, but this is the fastest. Okay. So ln y is this, and now you use the product rule on this piece. Okay, so how do you do that? Again, this one is 1 over y times dy dx, or y prime. And now sine gives you cosine times ln x. Let me just put a raised dot in between. So we are multiplying sine x by ln x. So the derivative of sine, cosine times ln x. The derivative of ln x, 1 over x times sine. And now all you have to do, y prime or dy dx, multiply both sides by y and replace it with x to the power of sine x. So class, this is y. So multiply both sides by y and replace the y with what it was. So this one is cosine x ln x, and this one you can write 1 over x sine x, or you can write sine x over x. Either way is fine. Sine x over x. Okay. It's pretty straightforward. I hope everybody is comfortable with that. Let's look at the last page of this group. All right, part A, we want to differentiate that. So just the way it's given, this is log, and this is the argument, and this is the base. Okay. So because it's log, you flip this over, times the derivative of this piece. 1 gives you 0. Remember, the is theta, that is like x, is the independent variable, and ln 3 is a number. So times ln 3. And then because the base is not e, times 1 over natural log of that. So one more time. Flip this over. The chain rule says times the derivative of the parentheses, ln 3. The change of base formula says since this is not e, 1 over natural log of that. This one cancels out this one, and you're done. Okay. Another way, remember the change of base formula. You could have written this one as this, and then differentiate it. But what we did was fast enough. You don't have to worry about that. When we do something like part B, again, knowledge of logarithmic properties is extremely important. So we can go through differentiation, or we can simplify and then differentiate. So we have log base 3 e to the power of sine t ln 3. So when you look at this part, you see the e to the power of sine t times ln 3. So if I change the order and I put ln 3 first, e to the power of ln 3 can simplify. Take a look. All I'm doing here, I'm saying it's sine t times ln 3. Why don't I interchange? Okay, so when I interchange ln3 comes first, and I'm looking at this part, never mind the rest of it. So it's the same as e to the power of ln3 in the parentheses to the power of sine 3. So what is e to the power of ln x? X. What is e to the power of ln3? Simply 3. So take a look at what happens. If it helps, you can rewrite it as follows. This part you can write as e to the power of ln3, the whole thing to the power of sine t. I'm sorry, class, I meant sine t. Put x sine t. And the piece in the parentheses just becomes number 3. So take a look. This whole thing, e to the power of ln3 is replaced by 3. So 3 to the power of sine t. Now take a look at this one. Log base 3 of 3 to the power of sine t. See, we are just doing algebra. We're just doing logarithmic properties. This simplifies. This is done. This simplifies to what? Simply put sine. So t times this part, which is sine. And now you use the product rule on those. The purpose of this question was to use logarithmic properties. So t gives you 1 times sine, and sine gives you cosine times t. And you just rewrite it. This is your final answer, class. This is your final answer. There is really not much to it. Okay. Everybody can hear me?